It is rather straightforward to actually turn the conceptual sketch about the merge sort into Java. Let's see how we can do it. And the source code has been made available to you. Let me show to you how you can get it. You just go to the example project, example recursion, and go under the sorters package, and you will see one of them is called merge sorter. That's what we're going to talk about this time. And then to really see the test cases, you can go to the test merge sorter. If you click on that, and if you run the test over here, you're going to see the green bar, passing all the 4 test cases. If you want to see the detailed test cases, you can go to the test sorter over here. So these are all the 4 test cases we did, including the base cases and also the recursive cases. You can definitely go over there. I'll rely on you to do that. Let's go back to the slides. The slide actually show the 2 routines that will be needed. One will be the merge routine, the merge sort routine. The other one will be the merge routine. So these are the 2 routines we have to understand properly. Let me switch to iPad over here. So these are the 2 fragments of code we have to understand. This one over here nicely corresponds to the diagram that I drew in the earlier part. Remember, we did an illustration over here. I just copied the diagram to over here, just a little bit smaller, but you will definitely see the correspondence I want to show to you. And this routine over here is a subroutine, or the helper method that's being called inside the merge sort routine. That's something we're going to talk about as well. Okay, let's now start with the top level over here. So we have the merge sort. I just called it sort. And the sort can be, in general, can be implemented differently. It can be merge sort, it can be selection, can be insertion, can be heap sort, can be quick sort, right? So that's why I just called this very general name. Given some list, we want to sort it and return the sorted list. So we declare the sorted list over here, and then we got number 1 and number 2. So these 2 are the base cases, right? So these 2 are the base cases. Let's just annotate them very quickly over here. So these are the base cases. And remember, the base cases are if the list is simply just empty. In that case, nothing to sort. And also, if the list contains only 1 element, in that case, also very little work we have to do. You can look at exactly how things are done. Okay, I'll leave that to you. And this part over here will be the recursive case that we spoke about earlier. Let me show to you the correspondence to the conceptual sketch we did. That's why usually it's good to have to clarify at the conceptual level how things are going to be proceeded. We calculate the middle point over here. That's exactly how we calculate it, right? And also we got the left and we got the right. So these 2 halves which I put in red, so these are the left and right over here, which are unsorted. And also we got the sorted left and sorted right. How do we get them? So these are the 2 sublists that are obtained from recursively calling the sort method over here. You can think about here, the sort and the sort over here are the recursive call of the same method over here. Right? You can think about the left split and the right split, and we try to recursively call the sort on them, and which will give us sorted left and sorted right. Exactly the sorted left and sorted right. And finally, we have to merge these 2 sorted halves into the sorted list, which will be the solution to the original problem over here. Right? You can see the merge over here. And of course, we gotta understand exactly how the merge is supposed to work. And we have already covered the merge routine in the earlier Q&A or the assignments, so that should not be surprising to you. I'm gonna let you study this code over here. So what I will do is later on I will talk about the running time for this merge routine, which is quite obvious what it is, but I will speak about it in the next part. And for now, for those of you who might still be wondering about how the merge is supposed to work, so here is the precondition for the merge routine. So the precondition is, the precondition for the merge method, which will take the left and also the right. Left and right are both sorted. This is very important for the merge routine to really proceed. Otherwise, you should really give some kind of like an exception, right? The precondition for the merge method would be both input list, left and right, are sorted. Right? For example, left over here is sorted, and also right over here is sorted. And if you want to merge it, well, quite obvious how it is supposed to be done, right? Let's try that. You can think about we maintain some kind of like a pointer to see where we are over here. right? In the beginning, we want to compare 24 and 17. Which one is smaller? Because we want the resulting sorted list to be also non-descending. So whatever that's smaller, it should really go first. In this case, we'll let 17 goes first. After this, we're going to move the pointer to the next position over here. That's exactly what you will see in the code over here. Okay, I'll let you find the correspondence. And we're going to now compare 24 and 31. In this case, 24 is smaller, so we're going to put 24 over here. After that, we're going to move the pointer of 24 into the next slot. But when I say pointer, I'm being a little bit informal. I really meant the I and J counter over here. It will work as if it was a pointer. Okay, and we're going to continue with this and the pattern, so I'm not going to waste your time. So after this, eventually we should really get, and then 31, 45, and also 50, 63, 85, and also 96. You can double check to see if you're convinced that this will be the output from calling the merge method on these two sorted lists. You can definitely check. Alrighty, so that's about the very quick walkthrough about the Java implementation. It's not complicated, so it's really important for you to understand exactly how the high-level steps should really work, first of all, from the earlier part. So you will see the exact correspondence in Java. So this really illustrates whenever you want to design some algorithm, it's really important to be clear about the pattern of the recursive call, and then you will be able to quite straightforward for you to turn them into the actual implementation. So that will be the workflow I would suggest.